Hi guys, welcome to our tutorial week 2 entitled Air Conditioning System Part 1. So again, this is a 2 weeks course of air conditioning system, both introduction and application. And here is the tutorial answers for week 2 air conditioning system part 1. Let's go ahead. Hi guys, so again, this is our times page for air conditioning system and refrigeration engineering. I need you guys to scroll down to week 2 air conditioning system part 1 in the tutorial answer. So here is hidden from you guys because while I'm recording this video, it is still hidden. Now, I'm going to unhide it as week 2 is established. And what you need to do is just go straight to the question. And you have 4 questions there. Alright? Okay, so this will be your reference. You can also click on HVAC tutorial week 2 and answers. And you will have some of the jotted answers in colorful fonts. And also in black and white fonts for the answers for each question. Okay, so you are going to use these as for your reference while I am going to use my PDF annotator to explain of the questions and answers. Okay, question 1 that we are looking at now, let's read them together. A BTU meter is a device that measures water flow rate and temperature difference between the water entering and leaving the property of an energy customer. Now, there are a few words here that might be very confusing. This is a BTU meter. A BTU is a British thermal unit. Device, meter. So it's a device that studies how much either Q dot, which is the rate, move in or move out from a closed or open system. Okay, now over time, the device measures and reads the amount of energy used. Water enters the property at 100 degrees Fahrenheit and leaves at 120 degrees Fahrenheit. That means around 20 degrees Fahrenheit is removed from the system. So it is an out. And the total flow rate of through the meter for a month. So here the keyword is month is 900,000 gallons. Right? Not liters, but gallons. What would be the monthly energy bill if the charges by the country or by the nation is 25 cents per every 1 million British thermal unit? Okay. Now, again, the equations is quite simple. What you need is, if you can remember, Q, M, Cp, delta, T. This is a dot because it's talk about rate. How much rate of energy is moved in and moved out. How much mass is moved in and moved out to and from the system. Okay, so the first one is Q in terms of BTU per hour is equals to M dot Cp delta T. Okay, now M here, right, will be this. Since M dot equals to V rho V dot, okay, it's volumetric flow rate. So let me reverse that, okay, to make clear some of these fonts. You can see here V dot is gallon per minute and 60 minute per hour. Why? Because we want to change it into hour. That's why we times 60. And here is rho. Rho is the density of water in terms of English unit. Alright, our CP is 1 BTU per 1 lbmf or pound mass degrees Fahrenheit, and the last one is the difference of temperature. Now, rho is given there, right? As you can see here, because we want it to be in pound mass per gallon, right? We must first know that what is the density if it's not given lah. What's the density of water in SI unit, and then you can convert to this. So this one usually is already given. This one is lbm over ft to the power of 3, or pound mass per feet cube. Feet cube is just like meter cube. Meter cube can change to liter. Feet cube can change into gallon. To change that, must change first 62.43, right, times, which is this one, 0.1337 feet cube per second for every 1 gallon. That is the conversion for gallon and feet cube, and you will get 8.33. Okay, now here is Q, which is in the unit of BTU per hour, okay, and V dot in terms of gallon per minute, and times 499.8 and delta T. So these equations come straight from this one. Okay, straight from that one, yeah. Now, but this problem, water flows in terms of month. So now we know that as the flow rate is 900,000, your QBTU of a month is equals the same as MCP delta T, but it is gallon per month, and this one is we've calculated just now, and this is your CP and this is your T in terms of Fahrenheit. So you plug in 900,000 gallon per month times 8.33 pound per gallon, and then 1 BTU over pound mass degrees Fahrenheit and 20 degrees Fahrenheit. So the answer is per month is 149,940,000 gallon per month. You times it with 25 cents per every million of BTU and you get $37. Okay. So the difference between our equations just now was, this is in gallon per minute, but this one is gallon per month. So what we did is we just changed them. This is your V dot, right? V dot, which is this one, and this is your rho. This is your CP, and this is your delta T. Okay. Right. Where do I get this 499.8? Which is from this calculation. So you just try it and you get this. This is the basic for per hour and minute, so on and so forth. This one is per month. Okay, next question. There is a client asking you to design the air conditioning system for a place to keep his cows inside. Identify the objective of design and discuss about this. This is easy question, and usually maybe question 1 or question 2 in your final exam. So usually you can copy and paste this from your slides. It's actually economics, the health and well-being of the animals and the worker, and plus any regulation by the government. So there are 4 of them: maintain indoor air quality, maintain inside design temperature, remove moisture, and change the air movement over the animals. So with these, you might have to memorize them. Very simple. Right. Next question. This will be very quick. Question 3. Make a sketch of a variable air volume reheat system that has 4 zones. Discuss the operation of the system in summer and winter. Now, to do this, you must know that it has 4 zones. Go back to your slides. Talk about multiple zones. Okay, so let me reduce the size like that. Okay, what you need is to redraw the whole multi-zones like this one. Yeah, you can see it's multi-zone. And you must have your MPS or motor positioning system. You must have your DM, right? DM is your damper motor. And what is missing here is a controller that talks about where or when does it has to close and open, which talks from these controllers. So you can refer to your slides. So as you can see, air move in to a filter, right, and then goes to a cooling coil, right? Cooling coil, since we want this to work in summer and winter. So here is your cooling coil, that means to cool down place. What is missing here is heating coil. This one can use in winter, this one can use in summer. Alright, so a cooling coil is usually placed at the same place where the cooling coil is, right? Heating coil is placed over there. So a fan will suck in all the hot air or cold air depending on the situation and move throughout all the zones. The zone will have its own variables and temperature system, and the controller will read and readjust to cool it or heat it up faster or more or less, right? And air returns from the zones will come on the same ducting, right, and go to a return fan. And now either it is purged out from the cycle, or you can close this and the air will return. You can close this as well and you will have a cycle of the same air. Sometimes you can open them to let fresh air in and out. Okay, so what is missing is the controller there. Okay. Next question. I think it's the last one. Yeah, it's the last one. Determine the difference between figure 4A and 4B and discuss about the type of air handler. So what are the differences? The difference between A and B is this is for single, this is for multi. Multi. Okay, which is this section that this one don't have. Right, so let me go back. And then let's go down. In figure 4A, heating and cooling coils are in series, but figure 4B is in parallel, which is very obvious. Figure 4A, a damper controlled by motors from outside air, exhaust air, and mixture of exhaust and outside air, but figure 4B dampers are manual. Right, that means these dampers you can open and shut it manually as there's no controller. Right, figure 4A system is single zone and figure 4B is for multi-zone. Okay, how do we know this? As you can see here, whenever you see there is an MPS, that means this is a multi-zone, and there is no MPS, then this is a single zone. Right, and then you have this single system, that means sometimes you want to cool, right? Sometimes you want it to be hot. And here, heating and cooling is separated or individualized. Sometimes room needs to be cold, sometimes room to be hot. Maybe in this case, you can have only 2 rooms or 2 zones. Number 2, there are zones that is hot and zones that needs to be cold. Okay, technically, basically, this is how multiple zone is designed. But sometimes, right, sometimes this section can also be placed after the filters, that you can have the whole section can be cold, the whole section can be warm at the same time, even though they are multi-zones. Okay, so that is a quick look of our tutorial, week 2 air conditioning system part 1. So I hope to see some of questions that you like to ask. You can bring them forward to me via Times. Also, you can ask via email if you want to include screenshots, if you like. Okay, stay safe. Bye.